Aura W4C4. Assalamualaikum dan selamat petang. Okay, class, please see the answer carefully. Chapter 4. Question 1. A 2.5 kilogram block, this is mass, slides down a rough inclined plane. Rough means there is friction force between the surface and the object of an angle 20 degrees, so this is symbol for theta, with the horizontal at a constant speed. Constant speed means that acceleration must be equal to 0. 1.2 meter per second as shown in figure 1. Sketch and label the forces acting on the block. Second, calculate the frictional force on the block. Okay, question 1 asks you sketch and label of the forces acting on the block. So this is inclined plane, this is object M. Okay, this is angle and the motion of the object is downward. Okay, first of all, if the object have a mass, so they must be axis weight and direction weight is downward. Okay, start at the center of the object. Second, there is a rough plane, so friction force exists for this case. So where is direction of friction force? Direction of friction force is opposed to the U. Okay, opposed to U. So label the force. And the third one is normal force. Normal force starting from the surface, pointing upward, and draw the arrow and label. So the angle between normal force and surface is 90 degree. And is 90 degree to the surface. Because the object and the surface is touched together, so normal force wujud. Saya transform ke dalam bentuk free body diagram. So this is kinetic friction, this is weight, and this is normal force. Don't forget to draw direction of U. Okay, katakanlah ini inclined plane. Shape inclined plane is triangle. So ini dia punya sudut. Kita tahu ini objek. Okay, ini ialah paksi X. So normal force berada pada paksi Y. And weight must be pointed downward. And this is kinetic friction. Kenapa bila saya transform free body diagram, okay, normal FK U weight W ni kita kena resolve. Kenapa? Okay, nak tahu kenapa? Sebab kita tengok balik gambar rajah ni, saya ambil triangle yang kecil ni. Katakanlah ini W, ni sudut. So ini ialah normal. So ini sudut ni 90 degree, 20 tambah 90, 110. So ini ialah 80. And then bawah normal force ni, saya buat satu line. So sudut dekat sini ialah 20. Sebab tu W ni kita kena resolvekan dia kepada komponen Y. Ini komponen Y. So dia akan jadi W cos theta. Okay, bagi komponen X, dia akan jadi W sin theta. W je yang ada sudut. FK dia betul-betul berada dekat komponen X. N betul-betul berada dekat atas komponen Y. Tetapi W ni dia between X and Y. Boleh ya kelas? Kenapa W tu kena resolve? Okay, second question, ask calculate the frictional force on the block. And after we draw the free body diagram, I transform W into this figure. Okay, as you can see, Fk, W sin theta is X component and NW cos theta is at Y component, and W is between Y and X component. So we must resolve W into Y component, it becomes W cos theta, and into X component, it becomes W sin theta. So I draw at here. You can see this is kinetic friction. This is center. This is W sin theta. And the acceleration atau the motion of the object is downward. Okay, so we must use the Newton's second law, which is equal to summation F equal to ma. For this case, Fk W sin theta is X component. So for this case, F in X component, and direction same with the U is W sin theta. So positive W sin theta minus Fk equal to ma. Equal to ma. Because the object move at constant speed u, so acceleration must be equal to 0. This is concept. So acceleration equal to 0. So kinetic friction equal to W sin theta, W equal to mg using the formula sin 20 degree. So mass equal to 2.5, G 9.81, sin 20. Okay, so the answer equal to 8.39 Newton. Okay. Okay, for question 2, two masses M1 3 kg, the motion is upward, and M2 equal to 10 kg, the motion is downward, are connected by a light string, same string, which passes over a smooth pulley as shown in figure 2. Calculate the acceleration of the system. A. Second, tension in the string. T. So this is direction of the object. So acceleration upward, acceleration downward. Okay, question 2, ask the acceleration of the object. Okay, first of all, we know that M1 equal to 3 kg, M2 equal to 10 kg. So for this case, the acceleration is for object 1 is upward and acceleration for object 2 is downward. And what is the force acting the block 1? So the force acting on the block 1 is tension and weight. So I label W1 and the acceleration is upward. And what is the force acting on the block 2? W2 and tension also. But the acceleration is downward. For this case, the object for M1 and M2 is moved in Y component. So, one object, second object. And we know that tension is a force must be direction outward of the block. Okay, outward of the block. Mesti keluar. Arah arrow dia mesti keluar daripada block. Contoh kalau M2, dia mesti keluar dari M2. So, arah dia ke atas. Okay. And we use second Newton's law, summation Fy equal to MA, and this is block 1 first, block 1, so I label M1. For this case, tension same direction with the acceleration. So T minus W, minus because W is opposite direction with A. So equal to M1A. This is equation number 1. For block B or block 2, block 2, summation Fy equal to MA. Kenapa Y? Sebab motion of the object dekat komponen Y. And you can see tension is opposed to the acceleration, but weight is same direction with the acceleration. So W2 minus T equal to M2A. So this is equation number 2. And we know that T from equation 1 equal to M1A plus W1. Plus W1. So this is equation 3. And from equation 2, W2 minus M2A equal to T. So this equation number 4. Sebab tali yang sama, so T dekat atas dengan T dekat bawah, mesti nilai dia sama. So I equate same equation 3 equal to equation number 4, T yang sama. So from equation 3, M1A plus W1 is M1 times G. And from equation 4, T equal to W2, which is M2G minus M2A. Okay, so M1 plus M2 in bracket times A equal to M2G minus M1G. So acceleration equal to 5.28 ms negative 2. Okay, you must substitute this value for M1, M2 and G. Okay, second question, calculate the tension. So we can use from the equation 3, tension equal to M1A plus W1. M1 equal to 3 kg, acceleration equal to 5.28 plus M1 equal to 3 times 9.81. Okay, so tension equal to 45.27 Newton.